So hello everyone, my name is Nishant. So today we'll be discussing on the topic database types. So introduction to the database types. So this presentation provides an overview of the key database types including key value, document, column oriented and graph databases. We will explore the unique features and use cases of each to help us understand the options available for your data storage needs. Key value databases. So here we have the simple structure, fast lookup, scalability, and the use of used cases. So in the simple structure, we have the key value databases store data as a collection of key value pair, providing a straightforward, flexible schema. The next one is the fast lookups. Accessing the data by a unique key allows for extremely fast read and write performance. Then we have the scalability. Key value stores can easily scale out to handle large amount of data and high traffic loads. And the last one we have the use cases. They are the ideal for caching, user session management, and other application requiring fast, simple, and data access. Then we have the document databases. So in the flexible schema, databases store data in flexible semi-structured document rather than rigid tables. Hierarchical data. Documents can contain nested structure allowing for more natural representation of complex data. Then we have the query flexibility. Rich querying capabilities enable powerful search and retrieval of data within the documents. Then we have the column oriented databases. So here we have the columnar storage, then we have the compression, and last we have the analytics focus. Columnar storage. Instead of storing data row by row, we are using the concept of column oriented databases which store data column by column, improving efficiency for much more analytical workloads. So coming to the compression, the columnar format allows for better data compression, reducing data store requirements and improving query performance. Analytics focus. Where basically the column oriented databases excel at analytical queries that aggregate and analyze large database, making them a great choice for business intelligence and applications. Then we have the at the fifth slide we have the graph databases. Here we have the network structure, relationship focused, and the last one is the flexible schema. So coming to the network structure, here we have the database. The graph databases store data as a network of interconnected nodes and relationship, mirroring the structure of real world data. Then we have the relationship focused. Here, the queries in graph database focus on exploring and traversing the relationship between the data and making them much more powerful for complex and connected data. So then we have the flexible schema. The flexible schema, the graph databases have a flexible schema-less design, allowing for easy addition and modification of new data types. Then we have the comparison of databases types. So here we have basically four types. First one is the key value, which is key value databases types. Then we have the document types. Then we have the column oriented types. Then we have the graph types. Key value, which is the much more simpler and the faster and scalable version. Coming to the document, it's much more flexible, hierarchical, and powerful queries. Then coming to the column oriented, so it's much more efficient analytics and compression. Then we have the graph, which is the relationship focused and flexible schema. So in the key value, which is much more simpler and faster and scalable. It is basically ideal for caching. First one, then we have the user session and the other application requiring quick access to the simpler data. In the document, which is the flexible, hierarchical, and powerful queries. This is basically this type of databases are basically suitable for content management, customer data, and the other application with complex and semi-structured data. Then we have the column oriented, which is much more efficient compared to the key value and document. It is like efficient analytics and compression. So it is well suited for the business intelligence, data warehousing, and other analytics workload on large data sets. At the last one, we have the graph, which is basically the relationship focused and flexible schema. It is much more powerful for applications with highly connected data such as social networks, recommendation engines, and knowledge graphs. That's all. So coming to the conclusion and the recommendation. Access your data. Here we have got the understanding of the structure, relationships and access pattern of your data to determine the best fit databases types. Then we have the evaluate database options. The it basically research the unique features, and at the same time it also uses the cases of each database types to identify the most suitable solution. Then we have the consider scalability. So choosing a database that can reliably scale to meet our current and future data and performance needs. So that's all. Thank you.